Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is examples 94 to 96 on resultant of the general force system rather. The strip type is supported by cable AC. The total weight of the structure is 400 pounds acting at point G, and the 50-pound force, horizontal force, represents the effect of the wind. The combined effect on the structure of gravity, wind, and the cable tension is equivalent to a single force acting on the base B. Determine the tension in the cable and the equivalent single force. So here is the figure, and the effect of this system is a single force at B. But before that, let's solve for the tension. Since the effect of the system is a single force acting at B, so we sum up moments about B. And let's denote the tension as T. And let's resolve it into its components. T cosine 45, because this 45, this is also 45 degrees. And this is going down the Y component, vertical component T sine of 45 degrees. So summation moment B, let's show the reaction at B. The effect of the single force, this is the single force, take note. So the moment of the resultant, which is FB, about B is 0. So that's also the sum of the moments of its components, which consists of these forces here. So considering counterclockwise positive, so we have T cosine 45 times 18, then the vertical component 0, then minus 50 times 12, or equals 50 times 12 plus 400 times 4. So T cosine 45 times 18, that's counterclockwise, equals clockwise moment. So T can now be solved. It is equal to 172.8 pounds. Then the X component of FB, assuming this is the final direction of the single equivalent force. So FBX is T cosine 45 minus 50 from the figure. So T 172.8 cosine 45, then minus 50. So FBX is leftward if this is positive. So FBX is 72.19 pounds because it is positive, so it is leftward. FBY, downward, so downward positive also. So it consists of T sine 45 and 400. So 172.8 sine 45 degrees plus 400. So FBY is downward, and it is 522.2 pounds. Therefore, expressing the single force FB into a single force and in vector form, it is equal to quantity negative 72.19 I minus 522.2 J pounds. So that's the tension, and this is the single equivalent force, equivalent to the effect of the system. Then for your part, replace the loading shown by an equivalent force coupled system at the center of the disk. So that's the disk. This is the center of the disk. Then replace the loading shown by a single force coupled system at the center. So this should be your answer. R center 34.32 I minus 5.176 J pounds, and horizontal couple at the center is 16.55 K pound foot, so it is counterclockwise. Example 95, resultant of the general force system. A 250 kilonewton force is applied to the bracket that is welded to the vertical column. Determine the equivalent force coupled system acting at point C on the center line of the column. So since there is only one force for the solution downward, so the equivalent force is now applied at C. So it is also 250 kilonewton downward. And in vector form, it is 250k, negative 250k kilonewtons. So R sub C is negative 250k kilonewton. But that is not yet the complete answer. It should be provided with couple. So summation moment about X, MAX that's the positive sense, but the moment of the 250 kilonewton is in the opposite sense. It is negative 250 times moment arm is this 0.45 meter or 450 mm or 0.45 meter. So MCX is negative 250 times 0.45 and it is negative 112.5 kilonewton meter. MCY, this is the positive sense if you apply right thumb rule, that sense, or if you look at position yourself on the y-axis, it is always counterclockwise. This is counterclockwise if you position yourself. You look at X, Z plane, so this is counterclockwise moment. But the moment of the 250 kilonewton force is clockwise, so it is negative 250 times 0.1 MCY. So it is negative 25 kilonewton meter. Of course, there's no mz because the force is parallel to the z-axis. So the complete answer for equivalent force coupled system, R sub C negative 250.0 k kilonewtons and M sub C or C of resultant couple at C is quantity negative 112.5 I, then minus 25.0 J kilonewton meter. So that's it for this problem, and for your part, the chef bracket carries the load shown. Determine ang horizontal force acting at point A and an arbitrary force at point B that are equivalent to this loading. So that's the figure and show that these are the answers. So FA should be 400.0 I kilonewtons. That's horizontal force. And the arbitrary force at B is negative 160 I minus 320 J kilonewtons. So that's it for your part. Then example 96, the tensions in cables BD and CE are 4 and 3 kilonewtons respectively. Determine a force coupled system at end A of the bent bar that is equivalent to the forces exerted by the cables on the bar. So here is the given figure. For the solution, first we have to express each tensile force into vector form. FBD 4 kilonewtons, then it is directed leftward along Y, so negative 1.8 J, upward along Z, so positive 0.9 K. So FBD is 4 kilonewtons times the quantity negative 1.8 J plus 0.9 K all over square root of 1.8 square plus 0.9 square. So FBD is equal to negative 3.578 J plus 1.789 K kilonewtons. FCE, the magnitude is 3. It is directed leftward along Y, so negative 1.8 J, backward along X, so negative 0.6 I, then upward along Z, 0.9 K. So FCE is 3 times quantity negative 0.6 I, negative 1.8 J, positive 0.9 K over square root of 0.6 square plus 1.8 square plus 0.9 square. So FCE in vector form is negative 6 over 7I, negative 18 over 7J, positive 9 over 7K kilonewtons. Therefore, the single force in vector form also is the sum of the x components, the y components, and the z components in vector form. So for r a x, it is equal to negative 6 over 7 only, and it is negative 0.8571 in decimal kilonewtons. RAY is negative 3.578, then plus negative 18 over 7, and it is equal to negative 6.149 kilonewtons. RAZ is 1.789, then plus 9 over 7, so it is equal to 3.075 kilonewtons. Therefore, the single force applied at A is in vector form negative 0.8571I, negative 6.149J, 3.075 K kilonewtons. So that's the force, single force. The couple, so we have to apply the components at B and C respectively. At B, we have to the left 3.578 and upward 1.789. At C, we have 6 over 7 left backward, 18 over 7 leftward, and 9 over 7 upward. Then MEX, this is the x-axis. If you apply right thumb rule, this is your right thumb. The curling of your four fingers is in that sense. So this is our guide for moment. That's the positive sense of moment about AX, positive sense of moment about AY, and the positive sense of moment about AZ. So AX, this component passes through parallel, so only 9 over 7 will have moment about X, and it is positive. You look at the moment of 9 over 7, it is positive. For these force components at B, 3.578 passes through A, which is also AX, so 0. So only 1.789 will have moment about AX. So both 1.789 and 9 over 7 will have positive moment about AX. Therefore, MAX is quantity 9 over 7 plus 1.789 times moment arm 1.8. MAX equals quantity 1.789 plus 9 over 7 times 1.8. So MAX is 5.534 kilonewton meter. MAY, because this is the y-axis, so these force components will have zero moment about the y-axis because they are acting on the y-axis. 6 over 7 passes through BY, so 0. This is parallel to AY, so it has no moment contribution. Only 9 over 7 will have moment about AY. And since its sense is opposite to this positive sense of moment, 9 over 7 times moment arm 1.2, 0.6 plus 0.6, 1.2. So moment about AY is negative 9 over 7 times 1.2. And it is negative 1.543 kilonewton meter. Finally, moment about AZ, this is the positive sense. All vertical forces will have two moment. 3.578 passes through A, and it happens that this is also AZ, so it has no moment. Therefore, don't mind these two force components. They don't have contribution to moment about AZ. 9 over 7 is parallel to the z-axis, so don't mind. So only this component and this component 6 over 7 and 18 over 7 will have moment about AZ. 6 over 7 will have positive moment, the same sense. You look at the sense. Its moment is in that sense, so positive. And its moment arm is 1.8. This 1.8 here. Then 18 over 7 is opposite, so it is negative. So therefore, moment AZ is 6 over 7 times 1.8 minus 18 over 7 times 1.2. So moment AZ, 6 over 7 times 1.8 minus 18 over 7 times 1.2. And it is negative 1.543 kilonewton meter. So expressing these results in vector form, the resultant couple at A, or moment at A, is the 5.534I minus 1.543J minus 1.543K kilonewton meter. So that's it. That's the complete answer for the equivalent force couple system at end A. For your part, the concrete T-beam is loaded as shown. Determine the equivalent force couple system at end A, then at end B. This is the figure. There are three forces. And take note of the leveling of the dimensions. You might be confused or wrongly assigned the moment arm. And take note that the dimensions are in inches, and the reported answer here, RA equals RB equals 10I plus 20J minus 40K kips, and moment at A is negative 15J minus 10K kip put. Take note, kip put. MB is negative 200I minus 15J minus 60K keep put also. So that's it for this sample problem video.